So back in the beginning when we started this in 2012, that's when the curriculum came in. They, I think the very first or second set of provincial exams, all of a sudden they put on it a reciprocal graph, which we hadn't anticipated. We thought it would be the three main trig graphs, but it actually involves all six. So we're going to look at tangent first, and then we're going to look at the reciprocal graphs of cosine and sine and tan. So you'll have 6 graphs that you need to know off by heart because you'll be doing transformations on them. And I've had in the past a reciprocal graph with transformations on the provincial exam. In the past couple of years, it's only sine, cosine, tan. But we can't really rely on it always being that, or I can really do that. So with that being said, let's do some information, some values. So let's start just not, this is a long table. Let's start at the positives. This will help us. When we're at 0 degrees, remember that tan theta is equal to sine theta divided by cos theta. So when we're at 0 degrees, what is our tan value? So my coordinate pair at 0 is 1, 0. What's tangent? You're going to need to have your unit circle correctly because this isn't going to work. So sine's going to go where? On top. Cosine's going to go denominator. So 0 divided by 1 is 0. Remember that alphabetic order, this is cosine, this is sine, right? So at pi over 4, I know that they're both the same. So that's going to be 1. At pi over 2, the coordinate pair is 0 and 1 now. What happens there? This is your undefined. Three pi over 4. Try again. Negative 1. It would be super helpful if you worked on these notes while we're going over the lessons. Not get yourself organized. Okay, at pi, I'm at -1 and 0. So what is it there? 0. 5 pi over 4. You're in quadrant 3 now. 1 positive 1, thanks. 3 pi over 2, undefined. 7 pi over 4, -1. And back at 2 pi, 0. All right, so we're given negative side of this. Negative pi over 4 puts me in quadrant 4. So what is it negative in quadrant 4? -1. Okay, I want you to look at the pattern, if nothing else. 0, 1, undefined, -1. 0, 1, undefined, -1. There is a pattern. So if you were to go backwards, 1, 0, -1, undefined. So if you were to hedge your bet, what do you think this is? You're going to get voted off again. Oh no. So what comes after undefined? 1. What comes next? 0. What comes next? -1. What comes next? Undefined. And slow down here after undefined. What comes after undefined? Positive 1. What comes after positive 1? Woo! That was tough. So undefined turn into asymptotes. Anywhere you have an undefined, that's an asymptote. The graph can't exist there. So if I were to do my increments, I'm going to be +1, -1. Now I'm in quarters, right? So pi over 2, 3 pi over 2, pi. I'm at 3 pi over 2, and that's not where I was. Where am I now? After pi, this would be 5. I don't have enough room. I really should have extended this. Quarter, half, quarter, half, quarter, half, quarter, half. Did I miss one? Feel like I did, but I think I'm okay. Would you know if I missed one? You will, because the shape will be funky. I have a question. If your shape was funky on your graph, would you, A, take time to erase it and redo it completely? B, try to figure out fixing that one part, or C, just leave it and hope I don't notice.
Depends if it's on the line.
Okay, fair enough. I love this. Yeah, I think I got all the points there. I made no promises though. So I think the first thing I'm going to do is I'm going to put my asymptotes on. So -3 pi over 2. That's this one. There's going to be a dashed line. Asymptotes don't have to have arrows on them. If you put arrows on them, it's not wrong. But asymptotes don't have to have arrows on them. The next time I see another undefined is -pi over 2. Okay. What's the distance between here and here? What's the distance between -3 pi over 2 and -pi over 2? Very good. Pi. Right? We got 1.5 minus a half. So you get 1, right? So you should know that asymptotes are happening because there's a pattern. Asymptotes are happening every pi. So if I'm at -pi over 2, not even looking at my table, where's my next asymptote? Where's pi? You travel a period of pi. -1/2? It's going to be a +1/2. Because the distance between those two numbers? Pi. Okay. Pi over 2, where's my next one? Where's my next one? Pi over 2? 3 pi over 2. You're adding pi. Okay. Okay. Look, I had a little bit of an increment error. All right. Should I erase the whole thing and start again? You hope they don't notice? All right. I'm hoping you guys aren't going to notice. All right. Let's lay our points on here. I'm going to go do my positives first. No, that doesn't really work. So I'm going to 0 and then to +1. So at -1/4, I'm at a -1. At +1/4, sorry, at 0, I'm at 0. At +1/4, and this essentially is my tan graph. They're weird. I always remember that they rise to the right. It's the positive thing to do, to rise to the right. Yeah, these switch. So this drops to here and that drops to there. So if it's positive, it's going to rise to the right, which is something that we do all the time. So this period, this is actually your period of a tan function. What's the period of a sine function? Your standard issue sine 2 pi. What's your standard issue period or cosine function? 2 pi. What's your standard issue period or tan? It's just a single pi. I know, we had a pattern and it totally threw us off. So now the pattern repeats. So if you can remember the first one, you're good to go with all the rest of them. Just make sure that these keep rising to the right. So this one would be at -1. This would be here. So my arrow would go up on that one. Sorry. There's no point there, sorry. So that's your basic tan graph. It's pretty exciting. You're going to have to do transformations on your tan graph. They're the least favorite to do. But say la vie, what we got to do. Okay, so we're going to complete the following chart. Amplitude of the tangent graph. So how high did it go? It is infinite. So the amplitude, that's supposed to be infinity. What's the period? We already talked about that. Pi. What's the domain? Are you looking at last year's notes?
No,
Pi over 2 what?
I would see
K pi.
have to get the
That's okay. So what does that mean? Right, so you did a general statement for an exclusion of x. But you couldn't just put pi over 2 because I had asymptotes every period, right? So that's what this is saying. This pi, now if this had been a cosine graph, this would have been every period would have been 2 pi, but we have an asymptote starting at positive pi over 2, and every pi, you see another asymptote show up. What about the range? This one's easy. What's the range? Yep. So you could say y is an element of all real numbers, or you could say negative infinity to positive infinity. Zeros of the function. Zeros of the function. This is the general statement again. So where does our first zero occur? Zero. Awesome. So you could say 0 plus, and we got to make a general statement because k pi. I like to put pi k, but that's okay. I know, but it makes more mathematical sense that here's your period and you can do this many periods. Just saying, that's the way I think about it. You don't actually have to put the 0. You could have just put that, and that would be acceptable too. I like to put the 0 because that's kind of what we've been trained to do in all our general schools. Y-intercept, there's only one. Where is it? 0. Asymptotes. Asymptotes is going to be a general statement, and guess what? You've already done it. It's the exclusion in the domain. So you know that your asymptotes actually occur every pi over 2, and then you're going to add a period to them. Not supposed to say KEI. I don't know why things only know. Not ready to work. It's Monday. Okay, your sine, cosine, and tan done. Okay? You're going to commit those to memory, you're going to get tattoos of them, life's going to be good. I'll tell you the assignment is on tangent. I don't think there's any reciprocal functions in there. I know. Don't worry, I'll put my problem stuff. But you will. Okay, so I was kind of nice, and I put in your completed cosine table for you. Am I doing cosine first? No, I'm doing sine first. And I'm looking at a cosecant. So all 6 trig graphs are fair game when it comes to the test, the quizzes, or exams. So you can expect to see them in those 3 places. Just FYI. All right. So if we have this completed table here, we're going to do the cosecant table right here. So that's the reciprocal function of sine. So since it was so nice to fill it in for you, you guys should be able to do this right away. So if it was 0, this is really saying 0 over 1. Reciprocate that, what do you get? You get undefined, you get 1 over 0. If it was 1, what's the reciprocal of 1? 1. What's the reciprocal of 0? Undefined. What's the reciprocal of -1? -1. What's the reciprocal of 0? Can I just write UD for undefined? Is everybody going to be okay with that? 1, undefined, -1, and undefined. Okay, so the trouble with the table that we use here doesn't give us enough information, but it's okay, we can work on that. Because we can pull some more sine values off our unit circle so we can graph it. So, what does undefined stand for when you're graphing it? What do these turn into? Asymptotes, right? So we know that we should probably put our asymptotes on first. Okay. Imagine those are all equal. Okay, so I put my asymptotes on. I have it at -2 pi. I like to put my asymptotes on first. It kind of gives me some boundaries. Another one at -pi here. There's another one at 0. Pi over, no. We do have another one. I have another one at pi. Oh, excuse me. And then there's another one at 2 pi. All right, so if I were to plot the points in that table, you're going to see my problem really quickly. I don't have enough data points because at -3 pi over 2, it's a +1. At -pi over 2, it's a -1. At positive pi over 2, the +1, -1. -1's over the graph. Somebody's swap up my own. Today's the 12th.
What's that? David's fault.
It's for sure it's David's fault. Okay, so that doesn't look like a very good graphic. I got some points. They are parabolas, and you know that because you've done a better job graphing than my table has here. So we're going to pick some values in between. So what I'm going to ask you to do is I'm going to do the positive first. So let's pick a value between 0 and pi over 2. You're going to look at your unit circle. Pi over 4. Perfect. So if I put in a pi over 4, you know that's greater than 0 but less than pi over 2, right? What sign of pi over 4? Root 2 over 2, right? So the reciprocal of that is going to be 2 over root 2. Now, any of you in your head know what that decimal point is? Could you graph that? 2 over root 2, what is that decimal wise? 0.70 something. I'm talking about 70. Can somebody do it? 2 divided by root 2. No. 2 divided by root 2. Oh, it does. You guys are right. Yeah, be great. This is 0.7. When you do the reciprocal of it, it's going to be 1.18 or 1. Okay, so I need another point that's greater than pi over 2, greater than pi over 2, but less than pi. So it needs to be in quadrant 3. Hint, hint, nudge, nudge, pick the same denominator. 3 pi over 4. So that's going to be a positive root 2 over 2. Do the reciprocal of it, you're going to be at a positive 1.41. So if I graph those are going to be greater on either side than plus. Now, if I do from the third and fourth quadrant, so if I pick a value greater than pi but less than 3 pi over 4, hint, hint, nudge, nudge, pick something with a denominator of 4. 5 pi over 4. So what's 5 pi over 4? Negative 1.41. And if you were to head to that in quadrant 4 when it's 7 pi, holy hell, that's close. So do I need to go on the table of values for these? I don't know why this is so slow today. So that's your reciprocal sine graph. It's a bunch of small parabolas. Bunch of small parabolas with asymptotes in between them. What is sine in quadrant 3 and 4? Is it positive or negative? You guys just found it, it's negative, it's your cast rule, right? So what you should expect is values in quadrants 3 and 4, which is here, are going to have negative values. You're just building on your knowledge. I think it's super exciting. What's the amplitude of this graph? That's the range. What's the amplitude? Infinity. How come? Okay, now you're talking range.
Oh, wait.
You're right, but that's the range statement. Amplitude is how high the graph goes. What's the max? Right? Infinity. What's the min? Negative infinity. So it's infinity. You can already jump across to my range. Okay, period of this one. How come it's 2 pi? I've asymptotes every pi. Why are you ruining my, why? But I was your teacher last semester. Did I? Crazy. Do you know why it's 2 pi? Remember that a period has to have a max and a min in it, right? If we only look at pi, that only has the parabola opening up. 2 pi is the parabola opening down. So you need to have a parabola opening up and a parabola opening down to be your entire period. You need both in it. You've got a max and you've got a min. If you go back up to the tangent function, it was the exact same thing repeating every time within that pi. So the period of this graph is going to be 2 pi. I forgot I taught this to you guys. Domain, what's the domain? XER, and we're going to do an exclusion statement. Not equal pi k, where k is an element of the integers. K range. This is a unison one. My guess is you want to do set notation. The bracket one? Set notation or interval notation? I just taught you some calculus. You weren't even here. We did grade 11 stuff in calculus. Super easy. There's a lot of grade 10 stuff in calculus. I don't know, like the math itself isn't hard, but putting the pieces together is a difficult. Okay, range, here we go. Lower limit is negative infinity, and I'm going to -1, inclusive. That's a parabola that's opening down. That happens in unison with +1 to positive infinity. Square bracket around the +1 because it is inclusive. Zeros of the function. Are there any zeros of the function? Nope. I'm sure people have told you this before, but you have to answer the question. You can't leave a blank. Because if you leave a blank, I don't know if you don't know, or if you know everything and there's not, right? Y-intercept. None. Asymptotes. So our asymptotes would be that exclusion statement here. Pi k, where k is an element of the integers. You could put 0 plus pi k, and that's perfectly fine. You good? All right, let's move on to our reciprocal cosine function graph. Again, I was sweet and nice and filled in the table for you here, but I have the same problem. I don't have enough information. So this would be 1, this would be undefined, -1, this would be undefined. This would be 1, this would be undefined, pi would be -1, undefined. You guys know all I'm doing is doing the reciprocal of those. I know, it's magic. So what's the problem with this information? Again, I don't have enough information, right? I need more knowledge. I'm going to draw my asymptotes just because I can. So when do my asymptotes occur? Every asymptotes occur every pi. They start at pi over 2. Okay. That one is totally different than the other one. Okay, so again, I just have dots. I don't really have much information. So I'm going to take some values in between. And so on this one, we picked pi over 4, right? And pi over 4, cosine-wise, would be, then the reason why I picked pi over 4 is nice and easy because it's the same. Root 2 over 2, do the reciprocal. 2 divided by root 2, and we said that was 1.4. Now in quadrant 1, we know it's going to be positive, right? And this makes sense that this would be a positive 1.4. So if you have a negative, that would mean your vertex is here and your next point's way the heck down here, which doesn't make much sense. Now, where else is cos positive? Quadrant 1 and quadrant 4. We want to actually work backwards. So negative pi over 4, that's going to be my other point. That's exciting. What do you think happens down here? Does the parabola open up or down? Yeah. And what would be that second point that we're looking for? So at 3 pi over 4, which would be here, okay. Is cosine positive or negative at 3 pi over 4? On your unit circle, 3 pi over 4 is located in quadrant 2. Is your cosine positive or negative? Negative. So for you guys who are doing it for the second time, are you more comfortable with your unit circle? Those of you doing it for the first time, everybody still have to do it twice? Are you guys as, I don't think you're probably as comfortable as these guys who've done it. How come I didn't finish these parabolas? How come? How come I didn't? It's not on the graph, but what's it really not in? What decided my restriction? My restriction is to go negative 2 pi to positive 2 pi. Oh, it doesn't say that. Oh, yeah. All right. There's a cosine graph. Now here's the thing. Do you notice the difference between the two? What's the opposite about them? Where the asymptotes are, I would say that there's a shift. That's the way I would have classified it. I'm not sure I would have said opposite, but if that makes sense to you. On a sine graph, where's your first parabola? Or first asymptote? It's at 0. On your cosine graph, your first asymptote is at pi over 2. It's shifted. Yeah. So if you look at the last page of your chapter 5 notes, I gave you guys the second last page, I gave you guys all 6 on one page. And so it should be the last thing in your chapter 5 notes. Anybody have all the chapter 5 notes here?
I do.
Do you? Is that because you left them here? Perfect. So, on the cosecant and the secant graph, the dash line there is the original cos function, and the original sine function is the dash line. So you just have to know where the zeros were on the original function and turn it into else instead of something else. All right, so let's look at the information. Amplitude. Amplitude. This one's not hard. Amplitude. Infinity. Period. The exact same as the other one. Too high. How come? How come, David? I explained it for the last one. Do you remember? No. I need a parabola opening up, and I need a parabola opening down. Include the period. Domain. Range. Range? I hear mumbling. I hope it's right. Negative infinity to -1, inclusive, in unison with +1 to positive infinity. Zeros of the function. Yes. Really? Not. Does this ever cross the x-axis? No. Good try. Okay, y-intercepts. Y-intercepts. Where does it occur? Occurs at 1. Asymptotes. Remember that's your exclusion statement from your domain. So they occur pi/2 plus pi k. K is an element of the integers. All right. Cotangent graph. I didn't even fill this one in. That's not nice of me. Okay, can somebody fill in this table for me at -2 pi? What am I at? All you need to do is look at your notes from the first page. We're going to fill this in really quick. 0, 1, undefined, -1, 0, 1, undefined, -1, 0, 1, undefined, -1, 0, 1, undefined, -1, 0. All right, so what do your zeros turn into? They become undefined. 1 stays at 1. What is undefined turned into? No, you're undefined 1 asymptote. It turns into a defined. It turns into a 0. A -0? Wow. Things are getting serious. We're going to -0s now. This is undefined 1, 0, -1. Undefined 1, 0, -1, undefined. 0, -1. Oh, I must have skipped something. Oh, I gotta go find where I made my mistake. 5 pi over 3? Okay. So Carson, what did you say happened when we did a reflection? Yeah. No, we talked about it driving to school.
Oh.
Right. Okay, sorry. Nobody's called me on not putting my increments on my y and x axis. Yeah, we're just throwing caution to the wind today. It's Monday, we don't, no reason. Do we? I'm a little traumatized. I have no idea how animals have math. There's juicy fruit and a camel and a bird, and they all include not carrying on Mondays or Wednesdays. Just Garfield. Okay. All right. My whole life is governed by non-real people. I love that. Not enough animals, not even human. Okay, we're good. All right. So -7 pi over 4 is a +1. -3 pi over 2 is 0. And then I am at -5 pi over 4 is a negative. So now what's happening? It's like a reflection, Carson, but why isn't it just a reflection? Okay, so now I fall to the right and rise into the left, kind of like a reflection, but what's the difference in this graph between a reflection and a reciprocal? What happened to my asymptotes? My asymptote shifted. My first asymptote was at pi over 2. -pi over 2 and pi over 2 is right-hand graph. And we have that almost that reflection piece, but it's very different based on where my asymptotes are. What's the period of this graph? Since we're here and we're talking about it, you would be correct. And I gotta say, ladies and gentlemen, this is probably not the difficult part. It's going to be putting transformations on these. I love the huff. Sigh, look, it just kills, your happiness. Putting transformations on reciprocal graphs and things like that. So it's one thing understanding the points of the reciprocal graph, but now you're going to have to put transformations on them as well. Your assignment today is only going to be on the town graph. Okay? So don't worry too much about that. So let's fill in the table about this cool town graph. What's the amplitude? Infinity. What's the period? Pi. What's the domain? XER. With the exclusion, X cannot equal. Where's my first asymptote? At 0. So X cannot equal pi k, where k is an element of the integers. You could also say 0 plus pi k, but you don't have to if you don't want to. What's the range? This is the easy one. What's the range? Negative infinity to positive infinity. Some of you might write YER, and that's fine. What about the zeros of the function? Yep, so my first one occurs at pi over 2. And then I'm going to add one every period, so every pi, where k is an element of the integers. Y-intercepts? Is there one? I looked to you, Carson, and you looked away. What's happening on our y-axis? There's an asymptote, so I cannot have a y-intercept. And asymptotes are going to be the exclusion statement, but please notice what changes. This is count equals, this is equals. Because you are giving the equation for the asymptote. Here you're saying none of the values of my function can happen there. Here we're saying this is my equation. So not equal, equal. Okay, those are all your 6 graphs.